Hello and welcome to another Math with Miss V video. Today we are interpreting scale drawings. So the standard we're looking at, solve everyday problems involving scale drawings of geometric figures, including computing actual lengths and areas from a scale drawing and reproducing a scale drawing at a different scale. We're not really focusing too much on that last part today, just the computing actual lengths and areas. So today we will use scale drawings to compute the lengths and areas of geometric figures, as I already said. So a blueprint. A builder is using a scale drawing to build a house. The figure to the left shows the blueprint of the family room. So we can see this rectangle here represents the family's room, and that it has dimensions of 3 centimeters by 5 centimeters, and that our scale is 1 centimeter in the picture represents 3.5 feet in real life. So our first question is, find the actual length and width of the family room. Okay, so there's a couple of ways we can do this. The first is setting up a proportion. So we can say that in the scale, according to our scale, 1 centimeter is the same as 3.5 feet in real life. So for our width, we can see that is 3 centimeters. So what would it be in real life? That's what we're being asked to find. So we can see that this is in a proportional relationship. What do I do to 1 to get 3.5? Well, I multiply that times 3.5. And what I do to one side of my proportion, I do to the other. So I'm going to multiply 3 times 3.5. And I get that x, for the actual width of the room, is 10.5 feet. Okay, now let's look at the length. So I have, again, in real life, we're comparing the drawing. So 1 centimeter to 3.5 centimeters, or 3.5 feet. We're given 5 centimeters, and we want to know how many feet. Okay, so we first did it using a proportional relationship, seeing how much they change by. We can also compare our proportional relationships across, comparing numerators to numerators. And I see I can change 1 centimeter into 5 centimeters by multiplying times 5. I'm going to do that with my denominator. I'm going to multiply it times 5, and I get the actual width of the room, which is 3.5 times 5, and that gives me, let me do some quick calculations, 17.5 feet is the actual width. So let's go on to our next example. So we still have the same scale for the builder, and we know that in real life, this room will be 10.5 feet by 17.5 feet. What is the perimeter of the actual family room? So we've already given the information we need to know. We just need to find the perimeter. So there's a couple of ways. We could add the sides. So 10.5 plus 17.5 plus 10.5 plus 17.5. We can multiply 10.5 times 2 and 17.5 times 2 and then add them. Or we can add them and then multiply, which is what I'm going to do. So we have 10.5 plus 17.5 times 2, because I have 2 lengths and 2 widths. So 5 plus 5 is 0, carrying my 1. 1 plus 0 is 1. 1 plus 7 is 8. And then 1 plus 1 is 2. So I get 28 times 2. 2 times 8 is 6, carrying my 1. 2 times 2 is 4, plus 1 more is 5. So I get that my perimeter is 56 feet. Now, remember, perimeters in 1 dimension, so we just leave our units as feet. Okay, Now, what is the actual area of the family room? So again, we're going to use our 17.5 and our 10.5. And we find area by multiplying our length times our width. So we're going to multiply these two numbers together. And forgive me, I'm not going to do this in my head. I'm going to use my calculator. So 10.5 times 17.5, and we get that the area is 183.75 feet squared. Remember that area is 2 dimensions, so we note that by putting a 2 on our units. And we have one more example, same room, same dimensions. So we already know it's 10.5 feet by 17.5 feet. And let's see what's going on for our builder this time. So if the owner decided to decrease the size of the family room by 25%, what is the new length and width of the family room? Okay, so we're decreasing, we're doing a percent decrease. So the owner, whoever's building this house, has decided this room's too big, I need to make it smaller. Okay, so there's a couple of ways we can do a percent decrease. I'm going to show you one using the equation method and one using the proportion method. So for our length, which is the 5 centimeters or the 17.5 feet, I'm going to use the equation. So when we use the equation, we start with the original length. I'm going to use a nice cursive L so we know it's not a 1. And then we subtract out the percent we're decreasing. And we find percent decrease by turning our percent into a decimal and then multiplying it by whatever our length is. And then what we get for this is our final answer. So we have 17.5 minus 0.25 times 17.5. So 17.5 times 0.25. It's 17.5 minus 4.375. And then we subtract minus our answer, and we get that the new length is 13.125. Now, I don't know, possibly the owner wants it this specific, possibly they're okay with rounding to the nearest tenth and saying 13.1 feet, but this is the new length. Now, to find our width, I'm going to use the proportion method. So we always put our original in the denominator, which is at 10.5. We put our percent over 100. And whatever's still blank is what we're looking for, which is the part we're decreasing. So I'm going to undo this division with multiplication. So x equals, I'm going to do 25 divided by 100 times 10.5. Times 10.5. So we're going down 2.625 feet. So we're going to say 10.5 minus 2.625. We get the new width of the room is 7.875 feet, or if we round that to the nearest tenth of a foot, 7.9 feet. And that is using scale in real life examples to find actual lengths and widths and to change our lengths and widths. So we did scale it, but we just didn't draw our new scale. Thanks for coming by this Math with Ms. V video. I look forward to seeing you in the future.